1827, biologist Robert Brown was looking through a microscope, studying pollen grains in water. He observed something amazing. The grains kept jiggling about and never slowed down even when he looked at them again much later. This became known as Brownian motion. But Brown himself couldn't work out what was causing it. It was Albert Einstein who realized the movement must be due to tiny, invisible molecules of water colliding with the pollen grains. Today, we call it the kinetic theory of matter. Everything is made of tiny particles, which we can imagine as tiny balls. These particles are in constant motion, and there are forces of attraction between them. It's how strong these forces of attraction are that determines what state the matter is in: solid, liquid, or gas. In a solid, the particles are packed very closely together in a regular pattern. They vibrate around fixed points, but are unable to move around freely. The attraction between particles is very strong. This means solids cannot flow. They hold their shape and have a constant volume. The particles in a liquid are still close together, but they can move more freely, so liquids don't have a fixed shape. And they can flow because their particles can slide over one another. The forces between liquid particles are weaker than those in a solid, but still strong. In a gas, the particles are much further apart, with just empty space between them. They move around rapidly and randomly in all directions, with only very weak forces of attraction between them. Gases do not keep their shape, but completely fill the container they're in. They can flow, and because there's so much empty space, they can be compressed into a smaller volume. Brownian motion can be observed in both liquids and gases because of the free, random movement of their particles, revealing a hidden world of matter that's constantly in motion, but is too small for us to see.